The Economy of Machinery and Manufactures by Charles Babbage 1832. Chapter 2. Accumulating Power. 20. Whenever the work to be done requires more force for its execution than can be generated in the time necessary for its completion, recourse must be had to some mechanical method of preserving and condensing a part of the power exerted previously to the commencement of the process. This is most frequently accomplished by a flywheel, which is in fact nothing more than a wheel having a very heavy rim, so that the greater part of its weight is near the circumference. It requires great power applied for some time to put this into rapid motion, but when moving with considerable velocity, the effects are exceedingly powerful, if its force be concentrated upon a small object. In some of the ironworks where the power of the steam engine is a little too small for the rollers which it drives, it is usual to set the engine at work a short time before the red-hot iron is ready to be removed from the furnace to the rollers, and to allow it to work with great rapidity until the flight has acquired a velocity rather alarming to those unused to such establishments. On passing the softened mass of iron through the first groove, the engine receives a great and very perceptible check, and its speed is diminished at the next and at each succeeding passage, until the iron bar is reduced to such a size that the ordinary power of the engine is sufficient to roll it. 21. The powerful effect of a large flywheel when its force can be concentrated on a point, was curiously illustrated at one of the largest of our manufactories. The proprietor was showing to a friend the method of punching holes in iron plates for the boilers of steam engines. He held in his hand a piece of sheet iron 3/8 of an inch thick, which he placed under the punch. Observing, after several holes had been made, that the punch made its perforations more and more slowly, he called to the engine man to know what made the engine work so sluggishly, when it was found that the flywheel and punching apparatus had been detached from the steam engine just at the commencement of his experiment. 22. Another mode of accumulating power arises from lifting a weight and then allowing it to fall. A man, even with a heavy hammer, might strike repeated blows upon the head of a pile, without producing any effect. But if he raises a much heavier hammer to a much greater height, its fall, though far less frequently repeated, will produce the desired effect. When a small blow is given to a large mass of matter, as to a pile, the imperfect elasticity of the material causes a small loss of momentum in the transmission of the motion from each particle to the succeeding one, and, therefore, it may happen that the whole force communicated shall be destroyed before it reaches the opposite extremity. 23. The power accumulated within a small space by gunpowder is well known, and, though not strictly an illustration of the subject discussed in this chapter, some of its effects, under peculiar circumstances, are so singular, that an attempt to explain them may perhaps be excused. If a gun is loaded with ball it will not kick so much as when loaded with small shot, and amongst different kinds of shot, that which is the smallest, causes the greatest recoil against the shoulder. The gun loaded with a quantity of sand, equal in weight to a charge of snipe shot, kicks still more. If, in loading, a space is left between the wadding and the charge, the gun either recoils violently, or bursts. If the muzzle of a gun has accidentally been stuck into the ground, so as to be stopped up with clay, or even with snow, or if it be fired with its muzzle plunged into water, the almost certain result is that it bursts. The ultimate cause of these apparently inconsistent effects is, that every force requires time to produce its effect, and if the time requisite for the elastic vapor within to force out the sides of the barrel, is less than that in which the condensation of the air near the wadding is conveyed in sufficient force to drive the impediment from the muzzle, then the barrel must burst. It sometimes happens that these two forces are so nearly balanced that the barrel only swells, the obstacle giving way before the gun is actually burst. The correctness of this explanation will appear by tracing step by step the circumstances which arise on discharging the gun loaded with powder confined by a cylindrical piece of wadding, and having its muzzle filled with clay, or some other substance having a moderate degree of resistance. In this case the first effect of the explosion is to produce an enormous pressure on everything confining it, and to advance the wadding through a very small space. Here let us consider it as at rest for a moment, and examine its condition. The portion of air in immediate contact with the wadding is condensed, and if the wadding were to remain at rest, the air throughout the tube would soon acquire a uniform density. But this would require a small interval of time, for the condensation next the wadding would travel with the velocity of sound to the other end, from whence, being reflected back, a series of waves would be generated, which, aided by the friction of the tube, would ultimately destroy the motion. But until the first wave reaches the impediment at the muzzle, the air can exert no pressure against it. Now if the velocity communicated to the wadding is very much greater than that of sound, the condensation of the air immediately in advance of it may be very great before the resistance transmitted to the muzzle is at all considerable, in which case the mutual repulsion of the particles of air so compressed will offer an absolute barrier to the advance of the wadding. 1 *, if this explanation be correct, the additional recoil, when a gun is loaded with small shot or sand, may arise in some measure from the condensation of the air contained between their particles, but chiefly from the velocity communicated by explosion to those particles of the substances in immediate contact with the powder being greater than that with which a wave can be transmitted through them. It also affords a reason for the success of a method of blasting rocks by filling the upper part of the hole above the powder with sand, instead of clay ramped hard. That the destruction of the gun barrel does not arise from the property possessed by fluids, and in some measure also by sand and small shot, of pressing equally in all directions, and thus exerting a force against a large portion of the interior surface, seems to be proved by the circumstance mentioned by Levaillant and other travellers, that, for the purpose of taking birds without injuring their plumage, they filled the barrel of their fowling pieces with water, instead of loading them with a charge of shot. 24. The same reasoning explains a curious phenomenon which occurs in firing a still more powerfully explosive substance. If we put a small quantity of fulminating silver upon the face of an anvil, and strike it slightly with a hammer, it explodes, but instead of breaking either the hammer or the anvil, it is found that that part of the face of each in contact with the fulminating silver is damaged. In this case the velocity communicated by the elastic matter disengaged may be greater than the velocity of a wave traversing steel, so that the particles at the surface are driven by explosion so near to those next adjacent, that when the compelling force is removed, the repulsion of the particles within the mass drives back those nearer to the surface, with such force, that they pass beyond the limits of attraction, and are separated in the shape of powder. 25. By the success of the experiment of firing a tallow candle through a deal board, would be explained in the same manner, by supposing the velocity of a wave propagated through deal to be greater than that of a wave passing through tallow. 25. The boiler of a steam engine sometimes bursts even during the escape of steam through the safety valve. If the water in the boiler is thrown upon any part which happens to be red hot, the steam formed in the immediate neighborhood of that part expands with greater velocity than that with which a wave can be transmitted through the less heated steam. Consequently one particle is urged against the next, and an almost invincible obstacle is formed, in the same manner as described in the case of the discharge of a gun. If the safety valve is closed, it may retain the pressure thus created for a short time, and even when it is open the escape may not be sufficiently rapid to remove all impediment. There may therefore exist momentarily within the boiler pressures of various force, varying from that which can just lift the safety valve up to that which is sufficient, if exerted during an extremely small space of time, to tear open the boiler itself. 26. This reasoning ought, however, to be admitted with caution, and perhaps some inducement to examine it carefully may be presented by tracing it to extreme cases. It would seem, but this is not a necessary consequence, that a gun might be made so long, that it would burst although no obstacle filled up its muzzle. It should also follow that if, after the gun is charged, the air were extracted from the barrel, though the muzzle be then left closed, the gun ought not to burst. It would also seem to follow from the principle of the explanation, that a body might be projected in air, or other elastic resisting medium, with such force that, after advancing a very short space it should return in the same direction in which it was projected. Notes 1. See Poisson's remarks, Ecole Polytech. Cat Yale, XXI, page 191.